Okay, welcome guys back in another video about inorganic chemistry. So in this case, we are going to talk about the isocyanide complexes. So basically, this is our ligand, right? This is our ligand. So when our ligand is connected to our metal center, we call it as isocyanide complexes. Let's take an example, just like this is a good example, like manganese complex. Okay, now the important things you need to know about this isocyanide ligands, right? First thing is, right? First thing is, these isocyanide ligands are strong phi donors. Sorry, strong sigma donors, which means now the initial bond forming, right? You need to know that when the initially our metal center is connected to our ligand, the ligand has to do the sigma donation. The ligand has to donate its electron density to a metal center first. That's our first step. So in that first step, these isocyanide ligands are dominant, right? They have strong sigma donor characters, but they have poor pi acceptance, which means they are not forming backbonding strong as carbon monoxide. It may due to this nitrogen atom, right? You know that in carbon monoxide, right, the oxygen is much more electronegative, right? So it can pull electron density from our carbon atom, which makes the carbon atom vacant for incoming electron density from our metal center. So backbonding can start do rapidly. But in this case, nitrogen is not as good as oxygen when it comes to electron negativity. So there will be not sufficient pull of electron density from the carbon in order to make the carbon a vacant for incoming electron density from the metal center. Now the carbon's electron density is not sufficiently pulled over due to the insufficient electron negativity of nitrogen. So there is a relatively considerable electron cloud around the carbon, which prevents the coming of metal center's electron density. So lower backbonding or not good as carbon monoxide, the backbonding effect of the isocyanide ligands. That is the main thing you need to remember. Okay, now let's move on. There are three main bonding modes of the isocyanide ligands. The first thing is we call it as bent mode. Right, it's like this. So here we have the metal center, and here carbon, nitrogen, and here we have a bent mode. So this may due to the some amount of considerable back bonding, right? So not a three bond. You know that. Yeah, the cyanide is not a good 5x status, but that doesn't mean they are not forming back bonding. No, they are forming back bonding, right? They are forming back bonding, but not as good as carbon monoxide. That is what I did. Right? You need to understand that carbon monoxide is the dominant back bonding effect. It shows the dominant back bonding effect, but isocyanide ligands, they are showing back bonding phenomena, but not as good as carbon monoxide. So if our isocyanide ligand can form back bonding for at least for some amount, right, it will create stronger bonds. Like here the sigma bond character is there, and it will create another phi character also between the metal center and the carbon. So you know that there are three bonds between the carbon and nitrogen here, just like this. But when the phi bonding is happening, the one bond will be broken. Otherwise the carbon will be unstable, which makes so I just made a mistake, so let me correct it. The bending is not between the carbon and metal center, it's between the nitrogen, right? Here we have the metal center, carbon, nitrogen. Let me, otherwise it will be a little bit confusing, so let me take it like this: nitrogen and iron. Okay, this is good. So here that at first this is our structure. So due to the strong sigma donation ability, the sigma bond is formed between our metal center and the carbon. Now the thing is, I have told you that isocyanide ligands are forming backbonding phenomena. It is showing backbonding phenomena, but not as good as carbon monoxide. So in case they have formed a 5 bond between our metal center and carbon, you know this is unstable. So what happens is this bond will be broken towards the nitrogen. So now nitrogen will have a the nitrogen will have lone pair which repulsed, right, which will repulse through this force, which make it a little bending character. This is why called as bent mode, right? This happens when the metal center can form backbonding phenomena with the carbon. So let's say we have a very highly electron dense metal center, right? When the metal center's electron density is much higher, it will give away its electron density towards our carbon. But if our metal center has very lower amount of electron density, it can't do the backbonding for carbon, right? It can't do the backbonding for carbon. So for higher electron dense metal centers, we would often see this bent mode because it can form the phi bonding. If it can form the backbonding with the carbon, so this bond will be broken towards our nitrogen atom to form the lone pair. But other thing you need to know is this backbonding over here, this is not strong as carbon monoxide, right? When carbon monoxide presents here, it will create a much stronger backbonding effects rather than the isocyanide ligands. The other type is terminal. So when our isocyanide ligand is forming a bond with our metal center, let's say our metal center is very low on electron density, so it cannot perform the backbonding. So only a sigma bond will be present between the carbon and metal center. So the 3 bonds will be there between the nitrogen and carbon, which make this a linear ligand. This is why we call terminal mode of bonding. So you can identify these two, right? You can identify these two based on the metal center. If your metal center can perform the backbonding phenomena, then it would often go for the bent mode, because when the backbonding is happening, there will be a phi bond between the carbon and metal center. There will be a phi character between the carbon and metal center, which reduce one of the phi bond to break to form a lone pair on nitrogen atom. It will give a bent geometry between the nitrogen, carbon and this our particular R group. But if our metal center contains very less amount of electron density, it cannot perform the backbonding phenomena efficiently. So only a sigma bond character will be present between the metal center and the carbon. All the three bonds will be there with carbon and nitrogen, which make it a linear one. So there is another one which we call as bridging mode. So we will talk about the bridging mode in next videos. So for this video, I need you to understand these two phenomena and how often this occurs, right? You need to be sure about it. If your metal center is copper, you know, basically the copper has high electron density, right? Copper 2 plus has high electron density. So if your metal center is copper, there would be higher possibility, right? There would be higher possibility to become our isocyanide group to become bent mode, to be in bent mode, right? The copper 2 plus having a higher electron density, so it can donate electron density towards the carbon to form this phi character, which cause to break this bond and form lone pair on nitrogen. It will go to the bent mode. So normally the bent mode is go with backbonding presence, terminal no backbonding. This is the main thing you need to understand. So I hope you get the idea. In the next video, we will talk about the nitrogen monoxide ligand.